If you've ever used Claude or OpenAI's deep research feature and wondered how to build it, you're in luck, because I'm going to show you how to do that in this video. Let's get started. The first thing I want to show you is how the script and how the agent works, and then I'll show you how to build it. So I've already gone through the steps in the lesson, and I do have my lab environment running. So the one thing I need to do, yeah, I think I got it all running. Let's just try to run it now. So Python deep research, this is the file name that I created. So the first thing it's going to ask me what I want to research. GPT-5 just came out, so I want to know how people feel about that. Do users feel about GPT-5? We'll be specific. OpenAI GPT-5. The first thing it does is it checks to see if it needs to clarify anything, and this one doesn't, so it's going to move pretty fast here. So there are no clarifications needed. It has a plan, so it generated 8 searches, so these are all 8 internet searches it's going to do. It's going to look at user reviews, sentiment analysis, satisfaction survey results, criticisms, comparison of GPT-4 versus GPT-5, social media reactions, user experience, and performance metrics. So it does that, right? It adds all these subqueries or these internet queries to its plan, and then it performs the search. So this performs a search through Tavily, and then it starts to collate results. So we got top 25 results, and it did deduplicate them, so we removed any duplicates. Then it's doing a fetch. It's going to go out and read the pages in the results so that it can get the text of the page. And then it's going to generate a report. So, yeah, so now the report's done. And if we refresh over here, we'll see a markdown file that we can open, and here's all the reports. It's not formatted properly to fit this small window, but nonetheless you can see it has an executive summary. We have key findings, we have conflicting views and risks, some data and numbers, open questions, next actions, and it's all sourced. So I'm going to show you now how to build this using this script file, and there's a ton of flexibility you have. So I just created a basic version of this, but if you wanted a different structure or you wanted it to be more verbose in certain areas, you can change that through the code and through iterating on it. So let's go ahead and get that started now. Now I'm going to show you how to actually build the agent. So if you're following along on SkillMix, open up, well, let me just go back. So if you're on the dashboard, go to projects, and then open up the build a deep research agent, and then click start lab and wait for the environment to load. If this is your first time seeing it, this is the current status of the lab being loaded. It's getting an AWS account ready and starting up a server, so it does take about 1 minute for all that to complete. Okay, once the credentials show up here, then the environment is ready. You may see an error, like a error with yellow text that says still trying to connect. And if that happens, you can just wait until the text turns green, or you can press enter and it will show you that it is ready. Then head over to the lesson tab and a couple prerequisites. So we are going to use OpenAI as an API. And here's the link that you can follow to get your keys. And then we're also going to use Tavily, and Tavily is a search engine that you can use with an API. So you are responsible for your keys security and also the costs associated with both of these. Tavily does have a free tier that I'm using, and then I have an existing OpenAI account. So go get those and then come back. Then we can just go into building. So I'm just going to resize a little bit and then just copy these commands. So we're going to install a virtual environment folder, and this creates a working space for us that we can use and install packages. So you can click the refresh button and you'll see the folder show up. We then want to activate it. So source VM bin activate. And then we want to install all these packages which our code will use. So let's go ahead and do that and then wait. You can get your keys right now, so we'll then have to export our environment variables, which will be done next. So I'm going to go ahead and do that. And then paste the key in. And I'll do it for Tavily as well. Okay, great. So we have the environment completely set up. Let's go ahead and create our file. So we'll just copy this name here and then create a new file, paste it, and we're good. Let's go ahead and open it. And then let's start off by doing the imports. So we've already installed every package, and then we import them. So the first one are a couple different kind of core Python library imports that we're going to use throughout the project. This whole range of imports are really just for formatting the output. If you recall to the previous segment of the video, there was really nice console output here, and these packages allow you to do that. So this actually ends up making the code a little bit more complicated. As you'll see when we get to certain parts of the code, it looks a little bit busy. So if you don't need the console output, then you can actually just strip this. Like if we were going to create an API, we wouldn't need all these packages because we're serving the results via API. So that's just a quick comment on those imports. And then we get to the kind of core of it all, which is we're importing from LangGraph, which is the core agent framework. We're going to import the state, graph, and start and end. We're going to import a OpenAI chat utility. We are going to import the Tavily client, and then these three things here are really just for reading web pages and formatting results. Okay. So let's go ahead and move on now to the state object. So this is actually something that we do with LangGraph. We are defining our state object, and this state object is what gets passed between all the different parts of our application, of our agent. So you'll see later that we have what's called nodes that are in LangGraph, and this state is passed on through to each node as the agent progresses through its task. And so we're going to store the user prompt. If you recall back to how the agent works, there was a clarification part. So if there was any clarification needed, that value would get stored here. This is just a Boolean to tell if it does need clarification or not. Then we have a list of subqueries. So these are all the searches that will be performed. We have our hits, which are results, and our pages, which are results, and we have the final markdown that we displayed. Okay, and then we want to create the LLM model. So later in our code, we'll use this to communicate with OpenAI, and so this allows us to set GPT-4o as the model, and we're going to set temperature at 0, so meaning that it's not a very creative output, it's more direct and consistent. And then we set up our Tavily client. So this is what allows us to perform web searches with API calls. And you can see we're passing in the Tavily key here. Okay, we do have 3 different functions that our nodes will use. And so let's go ahead and paste them in here and then talk about them. So nodes use. So we first have a web search, and this function it'll use our Tavily tool and perform a search for the query that the user puts in. And we can set results, and here we're setting a default of 5 results that we're asking from Tavily. And then we basically take the results from Tavily and we put them in a dictionary that we specify. So for each result, we're gonna store the URL, the title, the snippet, and the score. A snippet is a little bit of text that comes back from Tavily. We also have the ability to fetch a page. So our agent will need to, once it gets a search result, it gets a URL, and then it needs to go read the page. And we're going to use the Python library HTTPX to do that. And so it's going to be able to go read the page and store the HTML results. And we'll use those results later when we're doing our final reporting. And then we have a function called dedupe hits. This one will actually just make sure that when we have a bunch of web search results that we're not processing the same URL or same site twice, essentially. Sometimes search results can have the same site with different parameters or whatnot, and so we're just deduping that here. Okay, so we have those, and then we have the next part is kind of the bulk of the application. So the way that LangGraph works, if you're not familiar, is that we create a state graph, and the graph is a series of nodes and then edges. So edges are what connects nodes to each other. So our core nodes are a clarify node. So this takes the user prompt and then communicates with an LLM to see if we need to perform any clarifications, any additional follow-up questions. Then we have a node plan, and so this one, the planning node will actually generate a list of 3 to 8 web search queries that the agent will then complete and then read the results from. So we get, typically those queries there. Then we have a search node. So this is actually what goes off and performs a Tavily search and gets the results back. And we save those results in the state graph. Then we have a node that will go off and fetch each URL that's in the search results, read the page, and then synthesize it here in this step. So I'm just going to go ahead and grab all this, and then it's quite a bit to read through. So you can, take some time to do that, and you'll see that, let's just go through a couple of these. So on the node clarify, we're basically creating a prompt that says, you are a research assistant. The user asked this, which is what we'll pass into the graph. And then we then effectively, let's see right here. So we take that prompt, and then we use our LLM to invoke a call to OpenAI, and we get the results back. So this is the clarification step. So, something similar with the node plan, we're basically just creating prompts and then passing in certain information back to an LLM and getting a response back. So we do that with the planning stage, and this is again what gets us our 3 to 8 web queries. Then the search node, you can see here, it uses our web search function to go perform a web search using Tavily. And then our node fetch, so you'll see it uses our page fetch. Let's see, where did it go? Yeah, it takes each URL and goes and fetches the page using our function. And then we have the final synthesizer, which takes everything, sends it to ChatGPT or OpenAI, and then gets a report back via our prompt. And here's actually, just to call this out, so if you recall, our report structure had a very specific format, and here's how we set that. We said create a well-structured research brief in Markdown, and here are the sections that we want. And also here's the rules that you should follow. We want you to cite links. We want you to synthesize, don't just copy text. We prefer recent and authoritative sources, and if there's any conflict, say so. And so we're then passing in our sources, and we're passing in all the web data that we collected effectively. And then we make the call we do actually stream. We make a call to the LLM, and we stream the output. And then lastly here, we actually build our graph, and this is very specific to the way that LangGraph works. So we first initiate it by creating our LangGraph with the state. So remember in the beginning we had our state file, our state object. So we initiate the LangGraph with our state. Then we add each of the nodes, which I discussed. And then we have to add edges. So the way edges work is that they are from the start to all the way to how each node is connected. So the first edge we add is the starting one, and we we connect the start to the clarify node. Then we have a conditional edge here, which says if the needs clarification is sent back from from OpenAI, then we want you to ask for more details from the user. So we have a normal edge, and then we have a conditional edge that checks to see if we need to get any clarifications from the user. And then once the agent does that, then we just add the edges, the remaining edges. So we have a plan edge that connects the plan node to the search node. We have an edge that connects the search node to the fetch node. We have an edge that connects fetch to synthesize, and then finally synthesize to the end. And that's effectively how we're determining the flow of our agent. Alrighty. So we've done that, and then the last thing we do, I'm not going to step through all this because it's boilerplate code, and you can use the SkillMix AI agent if you want to learn about what this means and what it does. But effectively, when we use Python to execute this file, it'll call main, and then it'll check for our keys. It'll get the first user prompt, then it goes ahead and it creates the research state object, and then starts the whole flow of the program. And there's a bunch of code in here that's formatting the output for the console, which is why you see different statements like this. So this is how it works, and then you've already seen how it runs. We can do it again. What's the let's see if I spelled that right. I'm going to Hokkaido soon, so there we go. And you've already seen the output of this, so we can go ahead and stop the video there. So I hope you enjoyed it. Again, if you are interested in this environment here, you can go to skillmix.io, and you can see you go to skillmix.io and you can create an account here, and we do have like 3 free credits, so you can go ahead and take this and learn how to build a research agent using LangGraph. Thanks.